This project is a web application that uses Flask framework to implement a support vector machine SVM model. So let me show you here. These are the necessary libraries, Python libraries, which required for us to work on this project. We are importing Flask, Pandas, sklearn. From sklearn, we are importing a couple of classes such as standard scalar, SVC, which is nothing but support vector classification, and we are importing accuracy score and classification report. So, with all these components, such as libraries, we are going to work with this project. So, by the way, talking about SVM, support vector machine, with the help of SVM only, we are going to classify whether a person having diabetes or not. So, our project is about classifying whether a person is having diabetes or not with the help of the dataset diabetes.csv. Let me show you what it actually contains. Diabetes.csv contains a component such as pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and outcome. These are the elements. These are the things they took from the persons. From random persons, particularly women. So with the help of these dataset, we are going to find whether any persons here having diabetes or not. Okay, so let me show you. And in this project, we are going to upload the diabetes.csv file. It's over here. So we are going to load that. Then we are using standard scalar class, which is imported from sklearn preprocessing library. So what is this? What is actually this standard scalar going to do? Standard scalar is a data preprocessing technique used to standardize the scale of the input features in machine learning models. Standard scalar works by calculating the mean and standard deviation of each features in the training data and then subtracting the mean and dividing by the standard deviation for each feature. This transforms each feature so it has a mean of 0 and standard deviation of 1, which puts all the features on the same scale. Standard scalar is important when working with machine learning algorithms that are sensitive to the scale of input features such as SVM or neural networks by deep learning. By standardizing the scale of the input features, standard scalar helps to improve the accuracy and stability. In this project, we are using it to the input features of the diabetes dataset before training the SVM model. This helps to improve the performance of the model and make it more accurate in predicting whether a person having diabetes or not. So this is about the standard scalar. So next we are training the model using SVC, which is support vector classification. With the help of this, we are classifying whether a person having diabetes or not. Let me show you something which really works on SVC to classify the data, which is RBF, nothing but radial basis function kernel, which is used in support vector machine for nonlinear classification and regression. So basically it works by mapping the input data into a high dimensional space where it can be linearly separable by transforming the data based on the data distance between each data point and landmark point, which is called the center of the RBF kernel. The OBF kernel is particularly useful when the decision boundary between class is not a linear hyperplane. It can model complex decision boundaries and capture non-linear relationship between the input features and output variable. The RBF kernel has a parameter called gamma. Let me show you. See, it's right over here. So it actually controls the width of the kernel and determines the inference of each training example. A higher value of the gamma results in narrower and complex decisions, while a lower value of the gamma results in smoother and simpler decisions. So in this project, RPF kernel is used in HVM model to classify whether a person has diabetes or not. So we are training the model over here to classify, and here we are evaluating the model by returning the accuracy and the report through this accuracy report. Here we are predicting, which is testing our trained model, and app.root, which are Flask framework things, and these are get post HTTP requests from the Flask. We are requesting the file from the user, uploading. So let me show you the front end things over here. Index.html, where we are uploading the file, diabetes.csv, the dataset, classify, result, which shows the output, accuracy, and the report to the user. So now let me show you the working poster project. So by the way, we have run our application already, which is Python app.py. App.py is our application, and diabetes.csv result and index are our supporting files. So it hosted on localhost 5000. So basically, this is our project, which is hosted in localhost 5000. And let me show you how this project works. So this is where we have to choose the file, and I am choosing, yeah, let me show you. So project 1, yeah, I'm choosing the file. Let me see common separated value source file. So I am uploading it. See, I am getting the accuracy around 73%. So for non-diabetes, which is class 0, we got precision around 77%, recall around 82, and F1 around 8%. So for diabetes, the people who have diabetes is belongs to class 1, who have precision around 64%, recall around 56%, F1 around 60%. Yeah, the accuracy is nothing but how our trained model actually found whether the person is from diabetes side or non-diabetes side. How correctly it found is what the accuracy is. Actually, the 73% of the prediction is correct. Rest is not correct. That's what it. Uh, Let me show you something that we have done a monkey patching in this project, which is nothing but changing a behavior of a predefined class to get the required output a user needs. For example, we have used monkey patching in SVC class, support vector classification, for modifying the output which SVC provides to increase the accuracy. So we have done monkey patching to increase the accuracy of our project to do the classification and find whether the person has diabetes or not. Yeah, and we achieved accuracy around 73%. And we are working on the accuracy to increase by doing other algorithms such as linear